Hey science fans! Are you ready for another mind-blowing journey into the world of molecules and their incredible stories? Today let's talk about ozone, a molecule that's much more than just a chemical formula. It's a tiny molecule with a huge job, a silent guardian working tirelessly to protect life as we know it. While the oxygen we breathe, the very air that sustains us, is O2, ozone is O3. It's a subtle difference, but it makes all the difference in the world. That means ozone is made up of 3 oxygen atoms bonded together. Imagine 3 tiny oxygen atoms linked in a delicate dance. That extra atom makes ozone super reactive, giving it a personality all its own. And this reactivity gives it unique powers that are essential for our survival. Why does it matter? Why should we care about this seemingly insignificant molecule? Because ozone acts as Earth's invisible sunscreen, our planet's primary defense against the sun's most harmful rays. Imagine going to the beach on a bright sunny day. You use sunscreen to block UV rays, protecting your skin from sunburn and long-term damage. Ozone does the same for our planet, acting as a natural barrier high up in the atmosphere. It's constantly working, shielding us from the sun's harmful ultraviolet radiation, preventing it from reaching the surface and causing havoc. Without this ozone shield, life on Earth would struggle to survive. The conditions would be drastically different and much harsher. UV rays would scorch the surface, making it difficult for many organisms to thrive. They would severely harm plants, disrupting ecosystems and food chains. They would also endanger animals and us, increasing the risk of skin cancer and other health problems. So, this little trio of oxygen atoms, this seemingly simple molecule, is one of the most important protectors of life on Earth, a true planetary guardian. It's a perfect example of how something tiny, something we can't even see with the naked eye, can have a massive impact on the world around us, shaping the very conditions that allow life to flourish. Science is all about these hidden connections. It's about uncovering the secrets of the universe, one molecule at a time. But ozone's story is just beginning. There's so much more to learn about this fascinating molecule. So let's see how it can be both a hero and a villain, a protector and a pollutant depending on where it is. Remember, O3 is powerful, a force to be reckoned with, but its effects depend on where it is in our atmosphere and environment. Next we'll discover why location makes all the difference in the world of ozone. Stay tuned as we dive into the complex and fascinating the world of good and bad ozone, exploring its dual nature and its impact on our planet. The science behind this molecule is cooler than you think, and we're just scratching the surface. Let's keep exploring the amazing world of science together. Ozone. It's a word we hear often, but its impact varies dramatically depending on where it's found. Ozone's reputation depends entirely on its location in our atmosphere. It's a tale of 2 extremes, a molecule with a dual personality. The fascinating thing is, it's the same molecule, O3, but with totally different effects. Its impact on our lives and the environment hinges on its altitude. High up, far above us, in the stratosphere, ozone forms the famous ozone layer, our planet's UV shield. It's a natural sunscreen, a vital barrier protecting us from the sun's harshest rays. This good ozone absorbs dangerous ultraviolet rays, preventing them from reaching the Earth's surface. This protective action is crucial, safeguarding all life below from the harmful effects of excessive radiation. But down here in the troposphere, where we live and breathe at ground level, ozone transforms into a troublemaker. It's no longer our protector, but a pollutant. Ground-level ozone is a pollutant, a significant component of smog and poor air quality. It's not directly emitted, but created by complex chemical reactions between other pollutants, like those from industrial emissions and car exhaust and sunlight. It irritates our lungs, making it difficult to breathe, especially for those with respiratory conditions. It also harms plants, damaging vegetation and reducing crop yields, and contributes significantly to smog, reducing visibility and creating hazy conditions in urban areas. Think of good ozone as an umbrella in a rainstorm, essential protection from harmful UV radiation. Bad ozone is like opening that umbrella indoors, annoying, unnecessary, and even harmful to your health. The key takeaway: stratospheric ozone is good, a vital component of our planet's defense system. Tropospheric ozone is bad, a harmful pollutant that impacts our health and environment. Same O3, same molecule, but altitude changes everything. It dictates whether ozone is a friend or foe. Understanding this difference is crucial for informed decision-making and effective environmental action. It's essential for protecting our health, mitigating air pollution, and safeguarding our planet for future generations. So next time you hear about ozone, remember it's all about location. The context is everything. let's delve deeper and see how our invisible shield, the good ozone, is actually made. The story of ozone, its formation, its impact, and its future is just getting started. Ready to go higher to explore the upper reaches of our atmosphere? Let's head to the stratosphere and uncover the secrets of the ozone layer. Up in the stratosphere, the sun's UV rays split regular O2 molecules, freeing single oxygen atoms. These atoms quickly bond with O2 to form ozone, O3. This process happens constantly, creating a thin but powerful ozone layer. If you gathered all the ozone from the stratosphere, it'd only be as thick as 2 stacked pennies. Yet this thin layer absorbs about 98% of harmful UVB rays. Without it, we'd face more sunburns, skin cancer, and damage to plants and animals. The ozone layer is a filter protecting the DNA of all living things. It keeps ecosystems healthy and food growing. This invisible shield is one of Earth's most critical defenses, all thanks to a simple 3-atom molecule in the right place. Let's see what happens when ozone forms in the wrong place. Down in the troposphere, the air we breathe every day, ozone isn't made directly. It's not like it's emitted straight from a factory or a car exhaust. Instead, it's a bit more complicated than that. It's what we call a secondary pollutant. This means it's formed through chemical reactions in the atmosphere, rather than being directly emitted from a source. It forms when nitrogen oxides, NOx, which are released from various sources, and volatile organic compounds, VOCs. Another group of chemicals, from cars, factories, and power plants, mix together in a complex chemical dance. These are the primary ingredients in our ozone recipe, but they need a catalyst to get the reaction going: sunlight. On hot sunny days, when the sun's rays are at their strongest, these ingredients cook together, reacting with each other in the atmosphere like a simmering pot. This process creates ground-level ozone, a harmful pollutant that blankets our cities. This ozone is a major part of smog, that hazy, yellowish-brown air pollution we often see hanging over urban areas. And it can trigger a range of health problems like coughing, asthma attacks, and other respiratory issues. It can also cause lung irritation, making it difficult to breathe, especially for children and the elderly. But the effects don't stop there. It also damages crops and forests, impacting our food supply and natural ecosystems. It does this by interfering with photosynthesis, the process plants use to create energy from sunlight. Because of the sunlight requirement, ozone alerts spike in summer, when conditions are ripe for its formation. These alerts are designed to warn us when air quality is poor, advising us to limit outdoor activities. Unlike stratospheric ozone, which protects us from harmful UV radiation, this kind is a direct result of our daily activities, from driving our cars to powering our homes. The more we pollute, releasing NOx and VOCs into the atmosphere, the more bad ozone forms, exacerbating smog and its harmful effects. It's a clear example, a stark reminder, of how our actions directly impact the air we breathe and the environment around us. Ground-level ozone is a problem we can solve, but it requires a collective effort to reduce emissions. This starts if we understand its source and take steps to reduce the pollutants that create it. Next, let's see what happens when our protective ozone layer goes missing, and what the consequences are. The absence of this vital shield has far-reaching implications for our planet. The stakes are higher than you might think, and the potential consequences are quite serious. Let's investigate the case of the missing ozone and uncover the truth behind this environmental mystery. For years we didn't realize that chemicals we used like CFCs in fridges and spray cans could drift up to the stratosphere and destroy ozone. In the 1970s, scientists discovered that CFCs release chlorine atoms under UV light, which then break apart thousands of ozone molecules. The alarm sounded in 1985 when a massive ozone hole was found over Antarctica. This wasn't a literal hole, but a dangerous thinning of our UV shield. Cold Antarctic conditions sped up the destruction, making the problem worse there. The world responded with the Montreal Protocol in 1987, banning CFCs and similar chemicals. This global agreement is one of the biggest environmental success stories. Thanks to international action, the ozone layer is slowly healing. Scientists expect it to recover to 1980 levels later this century. It's proof that science, policy, and cooperation can solve even global threats. Now let's see how ozone's power is harnessed for good. Ozone's reactivity makes it a powerful cleaner in controlled settings. Cities use ozone to purify drinking water, killing bacteria and breaking down pollutants. After cleaning, ozone reverts to harmless oxygen, no chemical residue. The food industry uses ozone to sanitize produce and prevent spoilage. Some paper mills use ozone instead of chlorine to bleach pulp, reducing pollution. Ozone's cleaning power helps us find safer, greener solutions. It's chemistry working for us, when used wisely. Ozone's story is a balancing act, protecting good ozone above, reducing bad ozone below. The Montreal Protocol was a huge step, but we must stay vigilant. Harmful chemicals linger for decades. Meanwhile, fighting ground-level ozone means cutting pollution from cars, factories, and power plants. Cleaner technology, smart policies, and personal choices all matter. Our goal, a strong ozone layer in the sky, clean air on the ground. Both are vital for a healthy planet. Understanding ozone helps us protect what matters most. Let's see how you can help. You can make a difference for both good and bad ozone. Dispose of old fridges and air conditioners properly. Don't let harmful chemicals escape. Drive less, use public transit, and keep your car well maintained to cut pollution. Choose low-VOC paints and cleaners and use them in ventilated spaces. Save energy at home to reduce power plant emissions. Stay informed and talk to others about ozone's importance. Support policies and companies that protect our atmosphere. Every small action adds up. You're part of the solution. Ozone's story shows how everything on Earth is connected. Our choices affect the air above and the life below. The Montreal Protocol proved we can solve big problems together. The fight for clean air and a healthy planet continues. By protecting ozone, we protect ourselves, our food, and our future. Science, innovation, and action make a difference. Let's keep our planet resilient and beautiful. Stay curious and keep exploring.